Alright, today's lesson is about solving radical equations. Equations with radicals that have variables in their radicands are called radical equations. To solve a radical equation, isolate the radical on one side of the equation. That's going to be one of the big things. Isolate the radical. Alright, then raise each side to the same power to eliminate the radical and then solve the resulting equation. And then make sure you check your solutions here. Now, a couple of things that mess up the solutions. If you ever have the square root of something, let's say like x plus 10 equals, I don't know, like a negative number or something like that, a square root can never equal a negative number. You will never square root anything and ever get a negative number. So right then and there, if you see that, that's going to mess up solutions. And then sometimes if you go and you have something like this, x plus, I don't know, 7 equals like another x on another side, so multiple variables. When you square a variable, that's going to generate two solutions typically, and then one of them might not work. So you need to check solutions, I guess, with multiple x's. So look out for those. That's typically what's going to mess up radical equations. So we might see some of those, might not, I'm not quite sure. So anyways, with this one here, we start out real easy. To undo a square root, we square both sides. So that would be x equals, and then I guess 81 right there. Right, and if you think about it, if you plug 81 back in, square root of 81 is 9 right there. So yeah, to undo a square root, we square both sides. So nice and easy there. Now on something like this here, you have to isolate the radical, kind of like what we highlighted at the beginning. So we're going to add 16 here to both sides. That's going to get you 2 square root of x equals 6. And then I have a lot of people that want to square it right here at this step. You need to make sure the radical is all the way by itself. So we're going to divide by 2 first. And then once that radical is all by itself, that's when you can square both sides. So that'll get us x equals positive 9. And then if you want to go check it out, make sure it works when it plugs in. 2 times the square root of 9. The square root of 9 is 3. 2 times 3 is 6. And then 6 minus 16 is negative 10. So that does work out. Okay. C is another one where the radical is not by itself first. So we'll need to subtract 5 over. So that'd be the square root of negative, or I'm sorry, I'm writing that wrong right there. The square root of x equals negative 7. And this is like one of those special cases here. You can never have the square root of something ever equal a negative number. Now some people might not catch that, so they're going to go and square both sides. And when you square the negative, that's going to mess it up here. They're going to say, oh, x is 49. But think about this. If you take that 49 and you plug it back in, 49, or I'm sorry, the square root of 49 plus 5, that definitely is not negative 2. That's 7 plus 5, right? So that is not negative 2. So that's a special one. So really, it's at this step. If you can identify that the right side is negative before you square both sides, that's what's going to mess you up. So be on the lookout there for those. All right, with this next one here, we need to isolate the radical. So first thing, before we divide by 5, I want you to add 2. We'll write that as 3x minus 9. That'll be 15 right there. Divide both sides by 5. That'll get us 3x minus 9 is equal to 3. Or I'm sorry, the square root of 3x minus 9 equals 3. And then now we can square both sides. All right, now this time we'll have a few extra steps after our square step. So we'll have that. We'll add the 9 to both sides. That'll get us 18 right there, and then 3x. Once you divide, you'll get x equals 6. Okay, so not too bad on that one. Let's see what's going on with this problem right here. We'll add the 5 to the other side. All right, after that, we'll square both sides. That'll be 4x plus 1. The square and the square root will cancel out. Equals 25. We'll subtract 1, and that'll get us to 24. And then we'll divide by 4. That gives us x equals 6. So Not too bad on that one. That one's actually a little bit easier. Now sometimes you'll have two radicals. So like on this one here, what we'll need to do is square both sides. We still do exactly what we think, but now it's just so we square both sides, and now we got x plus 4 and then equals 3x. And then what I want you to do is move over that 4, or I'm sorry, move over the x. That gets you 4 equals 2x, and then divide. You get x equals 2. All right, and then if I did say if there's multiple x's, sometimes we want to go and check back and see if that works out. The square root of 2 plus 4, it's the square root of 6. And then the square root of 3 times 2 is the square root of 6 as well, so that should work out well. All right, a couple more here on the back one, kind of similar to that last one. Square both sides. It's 2x plus 5 equals x plus 7. And then I guess we can subtract x and then subtract 5, cancel out, so that gives us x equals 2. Nice and easy. All right, now these last two examples, these are the ones that get a little exciting, so I'd put stars next to these here, or some type of thing that maybe not look like a star there. So anyways, when we square both sides, we have the radical here by itself. We actually need to put parentheses around x minus 8 because we got to square that whole thing. And then I have a lot of students wanting to write this as x squared plus 64, square both of them, right? But actually, this is in a way a FOIL problem. This is x minus 8 times x minus 8. So we actually need to FOIL this whole thing together. That's going to get us x squared minus 8x minus another 8x and then plus 64. So then when you simplify that, that is x squared minus, I guess, 16x and then plus 64. Now over here on the left side, the square and the square root, they undo each other, so you have x minus 6 left over. And then what I would do is get everything to the same side. So we'll subtract over to right because it's a quadratic. With quadratics, you got to have them equal to 0, and then typically we want to factor. So I'm going to subtract x, and then I guess add 6. And that'll give us x squared minus, I guess, 17x, and then plus 70. And then we'll solve by factor. We need to figure out two things that multiply to 70, and then add up to negative 17. That'd be x minus 7 and x minus 10. And if you need some practice with solving quadratics, you need to go back and maybe check out some of those videos, or maybe find some videos on solve by factor. All right, and this means 0 equals x minus 7. Therefore, x is equal to 7. And then x minus 10 equals 0. So x equals 10. Those are your two answers. Now, like I said here at the very beginning, we said we need to check solutions when there's multiple x's. Like there is an x on the right-hand side. And especially since we got two answers here. So we're going to go and take back both of those answers, and I'm going to actually write it out here just to make sure we do it right. I'm going to take both answers and then plug them back in for x right there. So the first one will be the square root of 7 minus 6. And then we're going to see if that's the same thing as 7 minus 8. So the square root of 7 minus 6, that's the square root of 1, which is 1. But then 7 minus 8 right here, that's going to be negative 1 right here. And those do not equal each other. So therefore, x equals 7 is actually not a true solution. Then it has to deal with, squaring, both sides. When you square both sides, it's kind of like you're going to be squaring a negative number, which kind of messes things up. So anyways, now let's go and plug in the 10 and see what we get here. So square root of 10 minus 6 right there will be the square root of 4, and then we got over here 10 minus 8. So that'll be square root of 4, that'll equal 2, and the square root of 4 is 2. So that one works out. So 10 is your true answer in this case. So that is that. All right, now this last problem here, J, this is probably the most challenging type of problem that you can get. When you do square both sides, it's kind of like that last one where since you got two things over here, it's actually a FOIL problem. Over here on the left side, that would be 2x plus 1. Over here on the right side, you actually have to FOIL square root of x and then plus 1 times square root of x and then plus 1. Alright, so this thing's going to get real nasty here real quick. Now, luckily, square root of x times square root of x will just be regular x. Square root of 1 times x will be 1 square root of x, or you can just write it as square root of x. 1 times another square root of x is 1 square root of x, and then 1 times 1 will be, I guess, 1 right there. Okay, now I'm going to simplify this down. I'm going to say there's x right there, and then there's 2 of these square root of x's, and plus 1. And over here on the left side, we've got 2x plus 1. And then what I want to do now is isolate this radical. Now we only got it down. Now we got it down to 1 radical. So we're going to isolate this 2 square root of x real quick. So I'm going to subtract over x, and then I'm going to subtract 1. Not sure where that other 1 went. So those will cancel out, and then you'll be just left with x, and then I guess equals 2 square root of x. And then I guess we'll divide both sides by 2. Oh, I'm not sure where my, or no, we're good. So that'll be x over 2, and then equals the square root of x. And then we are going to square both sides from here. So that'll be just regular x, and then equals x squared, and then 2 squared, and the bottom is going to be 4. Okay. And then from there, we'll go and I'm going to rewrite this as 1/4 x squared, and then minus x, and then equals 0. I'm going to subtract over the x, and we're going to factor out one of our x's. 1/4 x minus 1. And then finally, after this, we're going to set our factors equal to 0. And finish solving. Multiply both sides by 4, so x equals 4, and then x equals 0. So that one takes a lot of work right there. Those are as hard as those types of problems get. And then I guess we just need to go back and double check here, plugging in our numbers here. If you plug in 0, 0 is not hard to do. 0 plus 1 basically inside that first square root. And then does that equal the square root of 0 and then plus 1 right there? And that is true. That'll be square root of 1. And that is 1. So 1 equals 1. That works out real well. And I guess let's go see if 4 works. So if I plug in 4, you get 2 times 4. And then I guess plus 1 still inside the radical. That'll be 8 plus 1, so that'd be 9. And then the square root of 4 plus 1 here, or I'm sorry, it's the square root of 9. The square root of 4 plus 1, that'll be 2 plus 1. And then over on the left side, you still have the square root of 9, so that'll be 3. So that'll be 3 plus 3, and that one works out. So both solutions work in this case. And that is that.